Hello and welcome to the presentation on RAMscaler, the fastest place to put your data. So in this presentation I'm going to go through what RAMscaler technology does for you in your data center, how it can improve the performance of your applications, and what I also want to talk about are some industry trends that we're seeing and the key differences between what we call in-memory storage and what the rest of the industry is calling storage class memory. So as we know, the fastest place to put your data is in memory. It is closer to the CPU on the board than any other place to put data. And we're seeing more technologies look to memory as the place for data storage. We're certainly seeing in the industry, technology companies like Intel put a lot of investment, engineering work into bringing data closer to the CPU to improve performance of applications, and doing that by making the memory devices look like storage devices and present those storage devices to operating systems so operating systems can consume them as storage. So we do things quite a bit differently with our RAMscaler technology, and we think that our approach to in-memory storage is the better one and certainly the easier one for customers to adopt. So we see this common and familiar interface, vCenter, and other hypervisors have other hypervisor management tools. And what we're seeing more and more often is what you see here. Large amounts of memory, in this case over 900 gigabytes of memory unused. And we're seeing more and more servers, compute nodes be deployed in data centers that have much more and more unused memory capacity. We're seeing this unused memory capacity never get used because the amount of virtual machines on these servers has reached a number that the customer is comfortable with. If there's a push to put more virtual machines on these compute nodes, then you get into other issues of risk and availability. And so organizations that I've certainly worked for in my career have told me that there's a certain number of virtual machines on each compute node they're comfortable with, and there's a policy within the organization not to go over that number. And so what we're seeing is more and more compute servers get deployed in data centers that have much more available memory capacities, and certainly we're seeing the maximum configuration capacity of these compute servers for memory be quite enormous and far beyond the requirements that the customer has. And so what we're seeing is this available capacity on all these servers become more and more of an issue because you want to drive efficiency. This is a very expensive area of storage capacity that you're unable to take advantage of today. And so what we've done at RAMscaler is we've built technology that can enable you to take advantage of this unused storage capacity that's in memory. And we create a very large cluster of that unused storage capacity, and we protect your data and any data that's stored in it, and we present that storage capacity back to the hypervisor. And so what we're solving in doing this is this issue of this unused memory. Now we can take advantage of that unused memory and start using it. And the other thing we're solving incidentally is we're putting data in memory, which means that storage latency goes down, potentially throughput goes up, and I say potentially because that's very network dependent, potentially IOPS go up. But what I can say is that this storage tier that RAMscaler storage is presenting to VMware and to other hypervisors can very easily become one of the fastest storage tiers in your environment, and potentially one of the most inexpensive because it's taking advantage of storage capacity in memory that's currently unused. So about 2 years ago, Gartner came out with this hype cycle. And as you can see here in this hype cycle, there are two areas that organizations are going to get very interested in. Those two areas are the areas of scale out in memory, and that's using technologies like RDMA and ROCE, RDMA over Converged Ethernet, and this concept of what's called in-memory computing. And we're definitely seeing now this prediction that Gartner had 2 years ago of this coming true. We're seeing organizations look very seriously at technologies that put all data in memory. And a very good example of that is SAP with what they've done with their database, HANA. And that's literally a in-memory database, completely in memory, and basically presenting the entire data set back to the applications from memory. The other technology companies that I can quote, companies like MongoDB and other ones that are really looking at leveraging as much memory as possible and putting as much data in memory and in cache as possible, and making cache become effectively a storage tier. And that's effectively what we're doing with our RAMscaler storage for all your applications without having to re-architect any of them. So we can bring this concept of in-memory computing to standard day-to-day applications that you're running in virtual machines, either on-prem on VMware hypervisors in your production data centers, or even in the future, with this same technology, we can apply this to public cloud environments as well, to your virtual private clouds in AWS, Azure, or even Google Cloud. So we are able to get your applications, and we're able to take the storage of those applications and stick that storage directly in memory with levels of compression that are enormous and with levels of performance that you'll see are very impressive. So RAMscaler is a memory-based diskless storage solution. Ultimately, it's what we call in-memory storage. And as this whole concept of in-memory storage and storage class memory gets pursued by many technology companies, we're seeing a lot of effort in this area of what's called storage class memory. And effectively, these are, memory-looking devices, but they're storage devices, and they're put into places of the server where memory traditionally goes, and drivers are used to basically tell the operating system that those devices are storage devices and not memory devices. And we don't think that's the best approach, and certainly not the easiest approach, because of the level of complexity required, specialized hardware, which is generally quite expensive. It's quite proprietary in a lot of areas, and there's custom drivers required in a lot of cases to get that approach into production. It does require downtime to deploy, and it requires specialized hardware. Our approach, what we call in-memory storage, is effectively taking unused memory that you have on your servers today across your data center, and large amounts of it, and clustering it all together and presenting storage from that memory that's available, clustered together, and with data protection and resiliency. So what we're really doing here is something extremely unique. And one of our advisors, someone who'd been in the industry for a very long time, said to us, this is very, very interesting. He said, back in the early days, VMware fixed this issue of unused CPU utilization, right, or capacity. And I remember when I was working, with customers, back in the mid 2000s, customers were really looking seriously about using virtualization to improve the efficiency in the data center, and they've certainly done that to a large extent. And what we saw in those days, or if you remember, is CPUs being about 5, 10, 15, 20% utilized. And by the implementation of a hypervisor, you were able to much more utilize those very expensive CPUs in those very expensive servers. And so what we're doing here is we're looking at another area that's becoming more and more unused. This large growing amount of unused storage capacity sitting in memory, which is a quite expensive medium in the environment. So what we want to do is help customers take advantage of this unused memory by using our software and presenting that unused memory as a very large storage tier back to the hypervisor, back to applications directly if that's needed. And this means that you get immediate improved efficiency in the data center, fastest access to CPU, lower latency, higher throughput potentially, but utilization of something that you're not using today, which is very important to many organizations. So why is this available, now? Why are we talking about this now? Well, there are more and more growing pools of unused RAM on servers. I've worked with many customers, some of the biggest banks in the world in health, and some of the biggest healthcare companies in the world. Looked in their data center, and I've seen in vCenter and in other management tools just this enormous amount of unused memory that's on all of these very expensive servers. And if you think about it, into the future, these servers are going to be delivered with even larger amounts of memory. And there's going to be an even more need to use that memory for something other than just memory for virtual machines. And so what we can do is help customers get to this concept, which is really the vision of RAMscaler, and that is a data center with no disk, or using disk really for secondary tiers of storage, or for backup, or for archive, and really taking advantage of this very, very interesting tier of storage capacity, memory-based, that will then become the storage for primary application storage, the primary storage for production applications, and particularly those applications that require low levels of storage latency or that can benefit significantly from low levels of storage latency or high levels of storage throughput and IOPS. So DRAM is now getting cheap enough to be considered for primary storage. If we think about where flash was back 10 plus years ago, flash was quite expensive. SSDs were very expensive. And so what did storage companies coming out with all flash solutions do? They built very, very good compression. And that's what we've done. We've got very, very good compression in our product to make small amounts, in some cases, quite small amounts of memory clustered together. So, as a cluster, it's a reasonable amount of storage capacity. But with compression, that becomes quite a decent amount of storage capacity that can be used. And the compression ratios that we've seen in the testing that we've done have really, for some data sets, been up to 10 to 1 and even higher. It really depends on the data set because some data sets are not as compressible as others. But at the end of the day, if you have very good compression, you can get price points per terabyte for this storage tier to be very competitive with existing storage tiers and potentially more competitive than existing storage tiers. So DRAM is now getting cheap enough to be considered for primary storage. Absolutely. And in the future, DRAM will be less and less expensive over time, to a point where DRAM might even be less expensive per terabyte than physical disk. Maybe not, but potentially so. Powerful file systems enable data protection, enable very large-scale clustering. And so what we're doing is we're deploying a solution that will spread your data across a large number of nodes in a cluster. And so your data is protected by the size of the cluster and by the resiliency that we've built into the file system. And so we're seeing other components of the infrastructure be much less resilient to failure than our storage. So, for example, we're seeing VMware's HA hit limits in its ability to start up virtual machines that were running on failed servers before our storage becomes unavailable for those virtual machines to start. So we're seeing other components on the network infrastructure and on the virtualization infrastructure, should I say, on the existing storage infrastructure potentially, being much more fragile to outage than our storage is. The other thing we've noticed in testing and doing certainly performance testing, our solution versus flash solutions, is that flash solutions have a limited endurance. So we know that flash devices are cell-based, and there are limits to the amount of times you can write to those devices, and applications that write very aggressively to those storage devices generally wear out those storage devices very quickly. And one thing we can say is that memory doesn't have an endurance limit. And so this is why, putting a cache in front of existing storage or using this technology for workloads that are very write intensive potentially, that can save your existing storage. It can make your existing storage last longer. And so you could potentially use RAMscaler storage as a cache or as a place to put applications that would otherwise really wear out existing storage infrastructure. And that means your existing storage infrastructure that you've made a heavy investment in potentially will last longer for you and become, over time, less susceptible to outage, to failure, and will continue to perform the way you want it to. The other thing we've noticed is that when SSDs get full, they get slow and unreliable. And that's for many reasons, too many to detail on this presentation. But, the simple one of the simple reasons is that, when SSD solutions, flash storage devices get full, new files that are coming in, new data that's coming in to be written, the storage device has to go and look for free space. And that free space, unlike when the storage device was new, that free space is not in a nice sequential area anymore. That free space is in random places all over the capacity that's available on the device. So at the end of the day, writes coming in are slowed by seeking for space capacity on the device, and flash devices and spinning devices too, spinning disk devices, SAN devices or NAS devices, they don't reorganize or defragment data structures. And when they and they don't, because if you did that all the time, you'd further exacerbate this issue of endurance, and so data then becomes over time very fragmented across the device, across the overall capacity on the device, and that means that not only writes are affected, but reads are affected too. And this is a matter of very small milliseconds, and some applications don't even notice. But it is a fact that when SSDs get full and when all flash storage arrays get full, they do get slow, or slower than they were when they were brand new. And that's actually not the case for memory-based solutions. Certainly DRAM, SDRAM-based solutions, we're not affected by endurance. We're not affected by performance degradation based on capacity utilization of available capacity. Applications do demand lower storage latency. There's more and more applications that are susceptible to latency, and these applications generally are one of your most important. So they're applications that are generally the most important applications in your environment because they're customer facing. They're running reservation systems, or they're running your website. They're running things that interact with end customers. They might be running the back end of a mobile application, for example. So improving latency, reducing latency is always going to make applications perform better. And as I said, often those are the most important applications you have. The return on investment for deploying RAMscaler is immediate. It's immediate because we're utilizing capacity that you already have deployed in your data center. Customers that we're talking to today are seeing as much value in this solution that they're looking to increase the memory capacity in their existing servers so they can use RAMscaler for more storage than they would if they didn't increase the memory capacity. So, customers that we've spoken to, they're looking at RAMscaler because they know they have enormous amounts of unused memory in the data center, thousands of servers potentially, and hundreds of gigs of RAM per server. And with our compression, we can present quite a large amount of storage capacity just from that unused memory. But what those customers are also looking at now is they're thinking, well, maybe if we increase the amount of memory in these servers, I don't need to go and spend $1 million, for example, on some, SSD or all flash or, very advanced, very fast flash-based storage system. That is another piece of hardware I've got to go and stick in a rack somewhere in my data center or replace an existing storage device with. You can get RAMscaler up and running very, very quickly in your environment, utilizing existing unused memory today. Present that data store back to VMware immediately. Start using it with no downtime. So applications that are on existing storage can be moved with no downtime to begin using RAMscaler storage instead. And then as you continue to refresh servers in your data center, you can now think about getting servers with larger storage configurations, which many of them are coming with anyway. And then fully utilizing those, larger memory configurations, which many of those servers are coming with anyway, and utilizing that memory for storage instead of what you traditionally use memory for. And alternative caching solutions are expensive, okay, and they put data at risk, and they sometimes require proprietary hardware to be put in your servers themselves or on the network. Caching is an area that people immediately think of being a quick way to solve storage issues and performance issues. And so one of the things that I point out to customers all the time is that caching puts data in a place that sometimes is unprotected. It's difficult to get data off those places, even if it has some type of battery backup or some type of protection of the data that's in the cache. Getting the data off those cache devices if there's a significant hardware failure is a big issue. So RAMscaler, we have data protection across the cluster. If nodes go down, we have the data on other nodes, and we replicate very, very efficiently across the overall storage cluster itself. Okay, so that's an overview of why this technology is important now. let's look at how RAMscaler works specifically, right? So basically, controller VMs are deployed on every physical host as an OVA. Easy to deploy. And these create these RAM disks from the memory that's being provisioned to those controller VMs. And we, with a management server, just similar to VCSA, vCenter, we connect to all these individual controller VMs and we build a very large storage cluster. And the management server enables you through a user interface to set up a storage cluster very quickly and then present that storage cluster with some configuration on the network to something, right? To VMware hypervisor cluster or to applications directly, anything, right? Anything that talks NFS. We can also talk iSCSI, but we recommend NFS in this configuration. And so with that, we cluster all these RAM disks together. We present them in a very highly available way over NFS back to the hypervisor. And then that hypervisor can then connect to the data store from NFS using NFS, and then consume the capacity in that data store. And you can very quickly then move virtual machines or containers or whatever it is you're running, over to this provision storage using an NFS connection. So we have this concept of worker nodes. Okay, so these VMs that are on all these individual VMware nodes. So they're just like general worker nodes. There's no management console. They just sit there. They're very small, easy to manage, easy to maintain, and they just sit there and provide this capacity from memory upwards to a network. And then we have this management server that basically gets all these worker nodes and provisions their storage capacity together as a clustered amount of storage, a very highly resilient cluster of storage back to the network over a standard connection protocol like NFS. Very simple to set up. Takes literally 10 minutes, and it's a bit longer if the cluster is extremely large. But this is a very simple solution to get up and running. And one of the things that is very, very important to point out, there's no downtime. There's absolutely no downtime in deploying this solution into your environment. Compression's built in, everything's built in, everything's easy to set up through the management console. So this is a very large market. We see strong interest in performance improvement, of course. In-memory computing is all focused on performance improvement. Zero latency computing. There's a lot of applications that very large organizations, particularly in the healthcare or financial services space, call zero latency applications. And these are applications where latency is the enemy, absolutely, and does have a massive effect on what the application is doing. Now, if you think about it in the financial services space, trading applications, things like that, getting that trade request in quick gives you a massive competitive advantage. But if you think about a front-end website that's basically maybe a reservation system for customers, to book maybe travel or rental cars or things, you want to make sure that, when the customer is clicking, on some search term or for a particular type of service you're offering, that response is quick. You want to make sure that the customer gets, impressed with the performance of their, requests for service. All right, and you get the performance up on customer-facing applications. You generally get an improvement in close ratio. You generally get customers buying things more quickly and less often going to competitive websites. If you think about it, we've all done it. If you're on a website and it's slow, you'll open another tab and you'll go to maybe that organization's competitor and have a look there and see what you can find. We know that, we get impressed if things are quick, take us through a process, get us to a sale. We generally get to that sale and proceed with it. So we're seeing excellent market potential here. We see obviously this market become very interesting. We're seeing organizations that are very traditionally in the storage space look seriously at what they should be doing around storage class memory and in-memory storage. But we're not seeing much innovation, actually. We're seeing some innovation on the storage class memory side, We're obviously seeing innovation around 3D XPoint, NVMe, and those types of technologies. But that's not a major shift from traditional storage, to be frank. That is a kind of a taking advantage maybe of improved performance between devices on the compute node itself. We're taking a very different approach to how storage is presented, much more innovative approach, and I actually think eventually the preferred approach to how we present storage from memory back to applications. So this market size is enormous, and we see huge amounts of innovation here, and we see really, really strong predictions on where things are potentially going in the future. And certainly we're seeing this progression from what you see on the right, on the top right in this sort of graphical image here. A lot of others, they're going from the right hand side and trying to get towards the left, as efficiently as they can without eroding their business, which of course comes in from a lot of technologies that are on the right. If you think about traditional storage companies like EMC, they're still making a lot of money selling pretty average technology, to be honest, and very old technology. So we're starting from the left. We have no intention to go to the right, obviously. We're starting from the left, and that's what we're going to be doing immediately. We're going to take that DRAM, SDRAM, fastest place to put data, where applications load data, so applications perform well. We're going to take that place, and we're going to enable applications to use it as their primary storage repository. So we don't think we have much real competition in this space other than traditional storage, and that's fine. We think we're offering a very different value area to what traditional storage does. But what we're really doing for customers is helping them unlock things they already have in their data center, that spare unused memory. Unlock that with our software and then start using that for applications. And look, if you don't like it, you can just uninstall our software. It's gone. There's no proprietary hardware. There's no racking. There's no plugging things in. This is easy to test. And this is the thing that I say all the time to potential customers. Look, just try it out. Try it out in your data center. There's nothing to lose. The OVA takes 5 minutes to deploy. The management console is super simple. You can get this all configured in under 20 minutes. There's absolutely no downtime. If you think about trying out storage class memory, it's a nightmare. You've got to stop servers, turn them off, open them up, put proprietary hardware in a lot of the time, or buy new equipment and rack it. And, this is super, super simple to try out. So please try it out. And if you don't like it, you can uninstall it. If you're not using it in production, you don't have to pay anything. But have a go and give us feedback. We would love to have feedback, positive or negative. Please give us feedback, and we will help you all the way if you need help getting this set up. So expensive all-flash arrays are probably the competition for us. Expensive hardware solutions with specialized device drivers like storage class memory, NVMe, 3D XPoint, PCIe flash. But we're not seeing any solutions out there really leveraging, some of this real innovation around, memory over converged Ethernet. And I know that requires, of course, very new and specialized network infrastructure, which not many organizations have deployed yet. But when you do, you can be comfortable in knowing that we actually can run over RDMA today. We can do NFS over RDMA in our product. With VMware's new support for PV-RDMA in virtual machines, so we can actually present, an RDMA-based storage appliance in a virtual machine, and we can send that storage traffic over RDMA over the virtual network and converged Ethernet. So in the future, when more and more organizations are thinking about using RDMA, for whatever reason, there's a lot of reasons for using it. This storage technology can support that. And over time, we'll have more and more better support for that and better documentation over storage performance improvements that you get with it. So the key value proposition here, as I'm sure you can see, leverage that unused memory today. Leverage it. Use it for this. You have to use it all, but you can use some of it. And some's better than none. This is easy to download and install. Download the OVA, deploy it. Easy, using vCenter. Works on all hypervisors and cloud environments. It does, but the first area of focus that we really are having is on the VMware customer. The VMware customer. If you're a VMware customer and you have a medium, large, even modest size environment, frankly, really look at this technology seriously. Run it up in your lab, or I'm not saying run it immediately into production, because obviously we'd want to make sure that you got used to it and got it configured really well, and to our recommended best practice. But test it, give it a test, give it a try, and give us feedback, please. We're the only software-defined solution that works seamlessly with both TCP and RDMA, as I mentioned. List price of $10,000 a terabyte. Now, that might sound to some people quite expensive. First of all, it's software only, so for volume, we will heavily discount. We're absolutely discount. And for our partners that want to work with us, presenting this technology to their customers, partners, please know that we have a lot of opportunity for marketing programs and other things here. This is an excellent technology to be presenting to your customers who get immediate value from this technology. But this price point actually is on par with some of the standard storage, hardware-based storage solutions that are out there that organizations are deploying. We, for example, compared ourselves with Pure Storage and with the Extreme IO, with some of these very, very expensive, kind of innovative, like storage class memory solutions, for example, and our price point is actually very competitive when you look at some of those technologies. And we're software only, so as I said, we for volume, we really can get into discussions about enterprise licensing agreements, unlimited use licensing, that sort of thing. Very, very open to that conversation. Of course, it's free for testing and evaluation, so you can just go and download it and test it, evaluate it, all for free, no transaction required. And because it's software, if it doesn't do what you are looking for, then you can uninstall it. No risk. There's zero risk to this. You uninstall it. There won't be any evidence of it ever being installed in the first place. Unlike other solutions, which are very complex, hardware installations often very complex to get set up and tested. This is a 10-minute investment of your time, a bit more than that actually, but at the end of the day, real quick to test and to evaluate. I also wanted to touch on performance a little bit more. So we're not selling this technology on performance actually, and the reason why is because performance is extremely subjective. But what I will say is that some initial testing that we've done has shown some significant performance numbers. By the way, these are not necessarily the performance numbers that you will see in your environment, because performance is all environmental. We are network based. If you have a very saturated network, then maybe performance won't be that good. But at the end of the day, it's a hyper-converged architecture. So, you get benefit from that immediately, that you're not sending data to a SAN and back. You're not going over a storage area network. That is not just expensive, but it's also, potential for, additional latency, and it's certainly, there are certainly issues of physical storage networks that you have to manage well. But as you can see here, we've got SSD-based storage, hard disk-based storage, and in-memory storage, right? So in-memory is, of course, going to be faster. And we're seeing, in-memory storage faster, up to 70 times faster than hard disk, 30 times faster than SSD. And it's just the nature of getting closer to the CPU. We're also seeing latency improvement. And to be honest with you, I think the latency improvement is really where the benefit is. And this next chart that I'll show you really does demonstrate where the latency improvement really is. So this is a virtual machine. This was taken from a virtual machine on VMware. Okay, and so what we did was we set up three data stores, right? With SSD data store, hard disk, traditional spinning hard disk data store, and a RAMscaler based data store. And what we did was we did a test, and then we storage vMotioned the VM to, another data store and did another test, the same test, right? So we put the VM, starting from the left here, or actually we start from the right. We put the VM on the hard disk-based data store, and then we ran the standard benchmarking tool that comes with Ubuntu, and we didn't install anything special here. And one of the things to focus on here is the latency. So the access time at the bottom. So 7.37 milliseconds, of latency. All right, with the hard disk-based data store. Over on the left, 0.7. Okay, so significant improvement. 0.7 and 10 times improvement. Latency improvement. But if you look at the RAMscaler data store, we're half that of SSD. And this is local SSD storage, okay? So it's local hard disk, local SSD, and of course RAMscaler is local because it's hyperconverged. So so you can see there's a really good performance improvement potential that you can get from using this solution. So this is kind of a final slide here, and it really shows the market segments we're addressing. A little bit related to the Gartner slide I showed earlier, but this area of hyperconverged infrastructure and server SAN and software server SAN is an area where there's a lot of innovation, a lot of investment, and strong interest. Traditional storage is diminishing significantly, and we're seeing that through this decade. We're seeing the scope for traditional SAN and NAS-based storage shrinking, and we're seeing this concept of hyperscale and hyperconverged and scale out storage architecture and really this interfacing with the public cloud and providing this sort of hybrid model that is the whole idea of hyperscale architecture, where you can scale out infrastructure limitlessly. So RAMscaler is designed for limitless capacity and limitless size, and we're leveraging file systems that, there's a theoretical limit. We've not hit those limits, of course. Those limits do exist, I will say, but those limits are very large, and most organizations would never reach those limits, frankly. And so the whole idea of this solution is to address this hyperscale area of storage, and of course this hyperconverged area and server SAN area of storage too. And we're seeing a significant market potential moving forward, and you can see how it's grown significantly over the last 6 years or so, and it's definitely on the same trajectory as customers look to build more efficiency into their data center, but also improve performance at the same time, and potentially hopefully leverage an area of storage capacity that you're not leveraging today, or that is not being leveraged today. So thank you for your time listening to the presentation. Please talk to us. Please download our software. Please go to our website. And please, if you're interested in a one-on-one conversation, or you would like us to do a whiteboard, a workshop, or anything around this technology, send an email to cto@ramscaler.com, and we will definitely get to you very quickly and provide you all the information you need to really get as much value as you possibly can from using this technology. Thank you again, and have a great rest of your day.